there's no mark allocated for you for doing FOIL. Okay, it's very important for you to know that FOIL is no mark. It's a basic step. Okay, so if then from here now, listen from here, we can introduce the double angle. Okay, here. You can introduce the double angle. You just rewrite this minus cos squared 15 degrees plus sine squared 15 degrees. This is the same as minus cos squared 15 degrees minus sine squared 15 degrees. Already I'm smiling and my heartbeat is normal. Right, so here your angle is 15 degrees. So we are using number one of the double angles for cos. Okay, so this theta we multiplied by 2. So our theta here is 15 degrees. We multiplied by what? By 2. So we get minus cos 30 degrees. And that will be negative square root of 3 over 2.
So wouldn't it be?
Yeah? Negative what? Can you speak properly? Okay. Are you following this? Following what happened? When you see this expression going forward, can I have your attention? When you see this, it should come naturally that this is difference of two squares. I hope, okay, just to remind you, I hope you are aware that algebraic expressions and factorization, they are opposites. I hope you are aware of it. So when you factorize this, you get that. When you simplify this expression, you get this. They are what? Opposites. Okay. So remember the difference of two squares. Then this one, those of you who have been paying attention from grade 10 with regard to perfect square trinomials, okay, they come a lot in trig. Okay, perfect square trinomials, they appear a lot in trig. So this, when you remove brackets, you get a perfect square trinomial. Okay, now, no need to use FOIL. Okay, no need to use FOIL. And no need to be scared because you saw that square there and there is cos alpha, sine alpha. This is like x and that's y from algebra. Are you following that? Huh? Okay, so square that, you get cos squared alpha. Then there's a minus here, so I'll put my minus. Then I'll multiply cos alpha by sine alpha, and then multiply by 2 that product. So I'll get 2 sine alpha cos alpha. Then I'll square that sine alpha, I'll get positive sine squared alpha. Okay? Are you following? Right? Then this sine 2 alpha. Okay, for now, let me not touch it. Okay? Because sometimes when you're doing trigonometry, when you've got a trigonometric expression like this, if you simplify, you can complicate things. So you must use your common sense, whether it's necessary to simplify at that moment or to wait a little bit. Okay, so I'm not going to rush to simplify it for now. Let me just rewrite it as is. So sine 2 alpha minus 1. Then let me simplify the numerator. Let the numerator guide me whether I should simplify this denominator or not. Okay? So cos alpha plus cos squared alpha plus sine squared alpha is a 1. So that will give me 1 minus 2 sine alpha cos alpha. This is all over sine 2 alpha. Already I'm smiling because I know that this is equal to sine 2 alpha. Okay, this 2 sine alpha cos alpha. Or I can convert, okay, I don't want to convert this to 2 sine alpha cos alpha. So I'll write as 1 minus sine 2 alpha all over sine 2 alpha minus 1. Okay, now from here we might have to use factorization to simplify things. Okay, we might have to use factorization, so I'm going to do that. Now, you are spoiled for choice from this step. Either you can rearrange the terms in the numerator or in the denominator. Well, I think for today I'm just simplify what's in the denominator. So I'll write this as 1 minus sine 2 alpha divided by, if I interchange these two, I'll get 1 minus 1 plus sine 2 alpha, then I'll factor out minus 1. So I'll get minus, open bracket, 1 minus sine 2 alpha. Okay? Once you get to this point, you'll be smiling. Okay? And your answer will be negative 1. Okay? Factorization is very, very important. Okay? If you struggle with trig, one of the reasons may be problems with algebra. Because algebra is the foundation of trig. Okay? And factorization is one of the most important concepts required to understand trig. All right? Any question? Any question? Any question? You're okay? Did you get it right? All right. Okay. Then, number 5. Can you pay attention? Pay attention. Right. The denominator here, the exponent is a 4. The exponent there is a 4. There is a minus a. What comes into your mind? Huh?
Difference of 2 squares.
Difference of 2 squares. Dots. One that you were introduced to in grade what? 9. Do you see how important it is? Grade 9 and 10, you did dots. So you need that thing. Alright. So for this question, I'm going to use number 1. Okay, please take note here, pay attention carefully. This is very important. I'm going to use number 1 because I know that if I factorize the denominator, I'm going to create an expression like this. So for this question here, the double angle for cos, you can't use 2b, you can't use 2c. If you use them, you are going to end up having major issues. You complicate the question. So always when you're working with double angle for cos, start with the mother. The advantage is that with the mother, you can always simplify and get 2b or 2 what? C. You can't just start with, say, 2c. You can end up having issues. Do you understand what I'm saying? Okay, so here I'll just write cos squared x minus sine squared x all over cos squared x plus sine squared x, which is 1 from grade 11, and then cos squared x minus sine squared x. Right? Obviously, these two are going to cancel out, and our final answer is going to be the 1. Because cos squared x plus sine squared x is a 1. You see how easy it is? Huh? It's not that difficult. Okay. Can I carry on? You okay? Right, so those of you who didn't do the homework, you somehow disadvantage yourself. You should have made a sacrifice to spend maybe 20 minutes to try and do those questions. Okay? Right, just to tell you, you have to manage your time very wisely. Okay.
And then 5 o'clock in the morning.
All right. This question. Okay, can we carry on, please? This question, when I was moving around, some of you had challenges, but it's so easy. It just requires your knowledge of algebraic fractions. Remember, grade 10, we did algebraic fractions. We need that. So, sine 39 degrees over sine 30 minus cos 39 degrees over cos 13 degrees. Okay? This question here, you have to find the LCD first. And the LCD will be the product of sine 13 degrees and cos 13 degrees. So the LCD is equal to sine 13 times cos 13 degrees. Okay?
No, I did it.
Now, since that's the LCD, how can you make this denominator to be equivalent to the LCD? So you multiply it by cos 13, you also multiply the numerator by what? Cos 13. Those are basics of working with fractions. Okay? Remove that. So this will be sine 39 degrees times cos 13 degrees minus. How can you make this denominator be equivalent to LCD? Multiply by this. So you end up, well, okay. In this case, I prefer to start with sine. Okay? So I can start with sine, so that will be sine 13 cos what? 39 degrees. Or vice versa, it's the same because of multiplication. Right? Then all over the LCD. Sine 13 degrees times cos 13 degrees. Alright? Okay? Now, the numerator, if you look here, the numerator looks like which set of equations? The right hand side of which equation? Number what? 4. Do you see that? It looks like this. So all you need is identify your alpha, identify your what? Beta. So your alpha is 39, beta, so that's beta is 13. That's how easy it was. Sometimes you can complicate the question when it's so easy. Just apply the basics. That's all. Okay? So this, since there's a minus here, it means I have to subtract this 13 from what? 39. So I'll get sine 26 degrees. This is all over. Right? This part now is very interesting. Right? It's very interesting. So I've got sine 13 degrees times cos 13 degrees. Right? This part is very interesting. Right? What I'm gonna do, I'm gonna bring that in and simplify that a little bit. Okay. Do you agree with me that I can make sine theta cos theta the subject in that first equation?
So now you're complicating it.
Okay? Right? So if I do that, I can end up having half sine 2 theta. Okay?
That's what I did.
This will be equal to sine theta cos theta. That's one way.
Yeah.
Right? Another way would be, this is a double angle here.
Yeah.
So we can rewrite it as 2 sine 13 degrees. Okay, I'll show you the other way. Cos 13 all over. Okay, wait, before we carry on, she's asking something here. Right, Munentre? You see number 4. Oh, it's a good thing that she's asking. Maybe she's not the only one who didn't understand where the 26 came from. At least she had the courage to ask. Thank you for that. All right. You see number 4 here. Can you all look, please? You saw me? Don't put the head down. You look here. Look here. We have a minus here. There's a product of sine and cos. Sine and cos there, which is what we have in the numerator. Am I right? Right? Because of this minus, it means on the left-hand side, we have to subtract beta from alpha. And for this question, our beta is 13, our alpha is 39. What is 39 minus 13? That's where the 26 came from. Are you following that? Yeah, the 26 did not just come from nowhere. It came from here. That's why I haven't erased these 4. Okay? All right? So let's move on. So this will be sine 13 degrees times cos 13. They will cancel out. I'm sure you can see that. They will cancel out. The final answer will be a what? A 2. But this is not the only way. Can I have your attention? Right, based on what, because remember what I told you the other day, we are different people, we see things differently. So, you should be aware that sine theta times cos theta is equivalent to this. So what that means is, this denominator, right, I can rewrite it as, okay, this probably should be an alternative to simplify that. You can write it as that, okay, that's fine. Then, you can end up, you see that sine 13 cos 13 is the same as a half sine 2 times 13 degrees. And this will give you 1 over a half, and you get 2. Okay? So if you can see it this way, it's fine. But you might also see it that way. You should get to the same one. Please take note of what I wrote here. Take note of this, because it might help you in future. Okay? Take note of this. Any question?